All right, and we are live. Welcome to our live chat for Wednesday, January 10th, 2024. We have a lot to talk about. Now, let's see here. We've had one winter storm that for the coast produced a little bit of snow, mostly rain. Interior, heavy wet snow. Most of that snowfall is now gone with our last heavy rainstorm that produced very strong winds. We have another heavy rainstorm that is on the way. But then we have support for two storms here that could be rather wintry, rather snowy for everybody. So I'm going to talk tonight about where we are in our pattern, what's evolving, what's generally developing here, and of course, what to expect with our rainstorm that's coming up for Friday night into Saturday morning, what I am concerned about for next week, the next storm beyond that, and then the pattern going forward. So let's dive into some of the data. And of course, as always, I will take all of your questions on YouTube. And of course, first on the premium chat, we'll go over all of your questions. Those are always paramount. Then we'll visit YouTube and see how that is cooking. As you can see, viewership is rising rapidly as we have just started on YouTube there. And I will answer all the questions. And of course, a lot of people are interested in not only the potential for snowfall for next week, but what about the rest of the winter? Is it done after this or what? So let's dive into the data and look at where we're at. So the first thing we're going to study is that we have an understanding first that El Nino's in control. We've already been through all that. It's starting to weaken, but there's a lag time between the rate that the El Nino weakens and the impact on the 500 millibar pattern. And by the time we really feel anything of that weakening and heading towards a neutral state, it'll probably be more like late March or April till we notice any real significant changes in the subtropical jet stream. So the key thing to look at right now is where is the MJO going? And the MJO is expected to linger in phase 3 for a bit and then rocket through phase 4, 5, and 6. Now, phase 4, 5, and 6 are warm phases, but look how fast this rockets right through those phases and ends up towards phase 6 and 7, and this is agreed upon on the European guidance and on the CFS guidance. So they're both kind of in the same realm here of moving the MJO back into phase 7 pretty quickly by the time we get to early February, and most likely towards phase 8 and 1 as we move into early February. So tropical forcing is pretty much in alignment with the idea, as I was discussing with premium members, of an active weather pattern in the next 2 weeks, plenty of cold air to work with, which we'll talk about in a moment, and an active subtropical jet stream with favorable phasing potential. Not guaranteed, but certainly potential there. Then we get a relaxation towards, I'd say, the last week of January, maybe the first couple of days of February. And then we see a reactive pattern once again in the subtropical jet stream to support winter weather once again over the eastern United States through about mid-February based on what we're seeing with the tropical forcing. Meanwhile, in terms of our polar vortex, we continue to see support here for our polar vortex to remain on the weak side and be a bit stretched. Now, I don't expect it to remain split like it is right now, but I do like the idea of a stretched polar vortex eventually consolidating and strengthening by the time we get to mid-February. So what does that mean? That means that the blocking that we're going to be seeing over the next 2 weeks, which is incredibly robust and it's directly related to the major stratospheric warming that we've seen and the split that we're seeing right now. Remember, there's that lag time between all of this happening in the stratosphere and the reaction in the troposphere. That evolution will support a gradual breakdown of the block and then redevelopment. So relaxation and redevelopment. So you have support at the tropical level, tropical forcing, and also in the stratospheric forcing, which is why we're seeing what we're seeing with the long-range guidance. Now, as I've said before, and I think we have all learned, you never take any of these forecasts out through February and March as verbatim, but you get the overall theme. And the overall theme is that we're going to continue to see support in February for a negative EPO with a trough or upper level low around the Aleutians, a ridge on the west coast, trough on the east coast, and the potential for some blocking, but nowhere near as strong as what we're going to be seeing over the next 10 to 12 days. Weak to moderate west-based negative NAO type signals, okay, where you could get a winter storm out of this, but it's not nearly as robust as what we're going to be seeing over the next 2 weeks. So that's where our winter is going at this point. Probably another couple of surges of polar Arctic air after this next wave of onslaught of Arctic air moving through. But that's kind of where I like this pattern going. Okay, we get that relaxation for the final week of January, first couple of days of February, and then we go back into it through mid-February, and then we start to back off towards late February and March. And then March likely is going to feature one of those intermediate patterns where we are unsettled, wet, raw, kind of disgusting out, and temperatures generally in the 50s, maybe pushing towards the 60s by the time we get to the end of March. But it looks like it's going to be a rather, not necessarily a cool spring, but a wet one at the very least, based on what I'm seeing with all of the data. So just kind of giving you an idea on that. So that's kind of where I'm seeing this pattern going right now. Currently, we're in the middle of transitioning from a focus of the polar vortex over central Canada towards more of the east coast. And so in order to get to that process and get the Arctic air into our neck of the woods, we're dealing with these lake cutters. And we have one lake cutter that lifted through last night, as you all know, very strong winds, very heavy rainfall, nasty conditions. And then you have these troughs moving through now. And you have polar air swinging on through the region. This polar air mass is a bit of an appetizer. Especially if you have any friends and family in the Great Lakes, they are about to see more snow than they could handle with the Arctic air ready to come in over these very, very warm lakes. And I'm mentioning this for those of you in the northern Mid-Atlantic because if you are in the Poconos and Catskills, you might be dealing a little bit more with some of the residue lake effect snow showers over the next 10 to 12 days, in addition to all of the synoptic situations going on with the potential for winter storms. It's going to get pretty interesting here in the Great Lakes, and some of that impact is going to reach the northern Mid-Atlantic in the form of snow squalls. So that's certainly something that we're going to have to keep an eye on over the next 10 to 12 days. But you can see when we zoom out, there's an awful lot of Arctic air to work with. It's just a matter of pulling it down. And that's exactly what these storms are doing. They're lifting northward, and you can see it even better with the 500 millibar pattern. I would stretch it to 250 millibar winds. They're lifting northward and building up heights towards Greenland and forcing this feature, this polar vortex, southward towards the United States, and that's why we're going to see that push of Arctic air. Now, we've certainly had a very impressive subtropical jet stream all winter, but we've been lacking the true Arctic air, as pretty much expected, where I said in the winter forecast, hey, my one concern with the winter forecast is that these polar air masses, for the most part, are going to be rather weak. And that is essentially what we've been seeing with a lot of rain snow mix on the coast and wet snow over the interior or rain snow over the interior. So we haven't seen that robust, strong Arctic air mass until now. And that is the primary key in this weather pattern over the next 10 to 12 days. We finally get the block in the Atlantic. We're getting the block in the Pacific. We have the Arctic air coming in, and our subtropical jet stream remains very active and full of moisture. So in the water vapor satellite picture, you could see all of the potential pieces here. We have the robust polar jet stream, which again, here is our next feature. It's going to be cutting up towards the Great Lakes, the final trigger to pull that Arctic air southward, and we're going to see a fundamental shift in our patterns starting on Saturday night into Sunday. The subtropical jet stream remains very active. And one of the things, the reason why I kind of walk you through all this is that instead of just pulling up models and saying, hey, model this, model that, model this, model that, these are the actual observations. So it's not a question of, hey, are the models right? Here are the observations where we're at right now. And so here is the potential that we have right now. And the thing to understand with atmospheric science is that it is the study of the conversion of potential energy to kinetic energy. The potential to, the ability to understand what the potential of the atmosphere is, and then seeing how that atmosphere works out. And of course, you throw in chaos, which is why it's so difficult to forecast the weather in these situations. So the first disturbance that's going to be lifting through here, of course, is going to be a rainmaker with the upper level low featured over the Great Lakes. Very strong PVA. Again, this is going to be a fast moving storm, but not as intense as the one we just had. There's going to be potential for some strong lifting and some heavy rainfall, especially towards midnight. This sounds familiar, I know. The wind potential is going to be there. As you can see here at 250 millibars, we have divergence and diffluence, but it's not as strong as the previous storm. We have our jet streak here with strong winds, but the difference here is that the mixing of those strong winds are not as impressive. And unlike the previous storm, this one has less potential for convective ability to mix down those stronger winds. But I still like towards midnight somewhere between 20 to 50 mile per hour wind gusts with this heavy rainfall as this storm lifts through the region. And as far as the rainfall is concerned, one of the things that we always like to study is the precipitable water, because the precipitable water tells you how much water is being held in the atmosphere. And in this case, we are basically ranging between 0.5 and 1.5. So that kind of limits your rainfall amounts to generally around a half an inch to an inch, with a few areas reaching up to an inch and a half in a few locations. So again, it's not the same intensity, not the same moisture, not the same heat content. So there's certainly potential for some strong wind gusts. And again, with the saturated ground and with the winds over the past couple of days, with these strong winds, there will be a potential for power outages just because the trees are going to be able to get knocked down far easier. And of course, there will be that potential for some moderate flooding continuing. In the meantime, we'll have plenty of warm air with this storm supporting rain. And then there begins our shift on Saturday night with colder air working in. And that brings us to our next storm. And our next storm that we're going to be watching comes in on Tuesday. And this is probably what everyone is very interested in, understandably. So there's a couple questions to deal with the storm on Tuesday. First of all, how strong is the shortwave in the subtropical jet stream? That needs to be sampled. And again, I'm sticking with my rule of waiting until we get under 120 hours to really go over the details. But one thing that is different from all the other storms is that this is a Miller A type storm, where we get a low pressure system developing on the Gulf and it tracks right up towards the mid-Atlantic coast. The question is, just how robust is this low pressure system development, and what is the exact track of the 850 millibar low? The forecast for Miller A storms is far easier for a meteorologist, because all you basically have to do is figure out the track. Once you understand the track, you know where to put the 850 millibar low, and you know where the gradient's going to line up. So then once you get all those factors in place, then you just follow general meteorological rules of where is minus 6 degree Celsius line. That's usually where you're going to find your heavier snowfall, northwest of the 700 millibar low, and away you go. So this forecast is going to have the potential of locking in a little bit faster. And the one thing that really kind of stands out to me that I'm a little concerned about, and we'll go to this point right here. On Tuesday morning into Tuesday afternoon and Tuesday evening. This gradient, this is some pure Arctic air. Now you might be saying to yourself, Stephen, yeah, of course it's Arctic air. It's winter. So what? Well, aside from the figuring out the snow ratio, which won't be 10 to 1, it would be more like 15 to 1, which is something that we definitely have to consider with our forecast, which is why I'm not even bothering with snow maps. But there's this factor. The sea surface temperatures off the East Coast. This is a situation where we're finally going to have a potential to maximize this thermal gradient. And when you have low-level cyclogenesis intensifying and you enhance that thermal gradient, you can get some surprises. You can get some rapidly intensifying low-pressure systems. And that could lead to not only a stronger low-pressure system, but also a low-pressure system that tracks a little bit closer to the coast. So there are some factors here that could make this a stronger, more robust storm than your typical 6 to 12 inch snowfall. Because, for one, you'll have the potential of a rapidly intensifying low pressure system, which some of the model guidance in the ensembles suggests. You got your regular run-of-the-mill 997 lows, but then you have some 986 millibar lows. And notice the track here is focusing more towards the benchmark. For those of you who don't know, this is a Costa and Ussolini researched factor, which, again, I strongly suggest if you're interested in meteorology, you pick up that book. You can get it from the AMS. It's outstanding. Whenever you get a storm track that tracks towards the benchmark, which is about 40 north, 70 west, that's usually a perfect track to keep cold air on the coast and set up some of your most significant snowfall in the I-95 corridor. And the majority of the models go in that direction. Some of them a little bit further west, some of them a little bit further east, but you kind of get the general idea of that track heading in that direction. So you have the potential here for a more intense low pressure system with a near perfect track with Arctic air to play with an enhanced precipitable water value, enhanced snow ratio, and plenty of moisture to work with. Sounds pretty good. So what could go wrong? I figure out, let me cover that before we go any further. Because I know everyone's kind of getting excited, like, oh, wow, this could actually be a real thing. The one thing to watch out for is that this track is a little bit too far west, and we end up with the immediate coast ending up with more of a rain-snow mix. Probably we would set up more like snow start off, mixing over to rain on the immediate coast and back over to snow, while the interior stays all snow. So that's certainly a potential. I don't see this being a lake cutter in any way, shape, or form. I see the furthest west that this track would be on the New Jersey coast. The further east this would be just east of the benchmark. So I'm pretty confident of there being a winter storm. It's just a matter of trying to figure out the details. Then, after this storm lifts on through, we have another storm. See, now this next storm around the 20th, this really has my attention. This really has my attention because you have the block. You have the 50-50 low. You have sustained cold air. And now you have another shortwave moving on through. This one could be another significant storm, again, working and interacting with the Gulf Stream here. Plenty of warm water off the coast, fresh Arctic air mass. A nice swing through with the shortwave here, nice interaction. I like the ridge axis here. Looks pretty favorable. So we'll have to watch to see how this evolves. The latest operational guidance does this kind of swing out move here with the 850 millibar low, which when you look at the operational does this one of these things. So what this would suggest is a low pressure system developing somewhere off the Delmarva and intensifying rapidly. When you have this type of scenario and you see all this bagginess, you see how the lines are kind of squirrely like this. Okay, that usually means that there's a lot of volatility and a lot of uncertainty of exactly where that shortwave is going to dive in and exactly how to redevelopment. This is more of a situation of a clipper that dives in and redevelops off the coast and can drop a pretty good significant amount of snow in a very short period of time. Again, in this scenario, you're dealing with, if I can pull up the right, here we are. You're dealing with a pure Arctic air mass, plenty of cold air to work with here. So it's not a question of whether or not it can snow. It's more of a question of what is the interaction in this scenario and what type of snow ratios are we dealing with. And when we look at this on the ensemble guidance, a little bit further out, you can see a nice indication here of a rapidly developing low pressure system off the Delmarva Peninsula or off the New Jersey coast that rapidly lifts towards New England. So you can end up with a nice burst of snowfall, let's say from about Philadelphia to Boston. But your heaviest would likely be from New York or northern or central New Jersey to Boston in that scenario. And Boston kind of misses out on the worst. So that is pretty much where we are at right now. We are entering a very active pattern. This is a time period where in the winter forecast I pinpointed and say, hey, look, this winter will be made or broken by 1 or 2 winter storms. And we are at that point right now. We got the pattern. Let me just go back to here. We have the pattern. I mean, that's as clear as day. We have the pattern locked in. You can't get a better pattern than this. We have the cold air. We have the active subtropical jet stream. Everything we've been talking about for the past 4 months is all here. And the question simply comes down to, do the ingredients come together to produce a snowfall or not? And that's something you can't forecast 4 months out. And I never have. But I've been expecting this pattern. It's here. Now we see whether or not it works out. And with that, now I am going to take all of your questions. Again, we'll start off on the live chat, answer all the questions, which are plenty of them. Outstanding, guys. And then, of course, we'll go to YouTube, and then we'll check out to see what insanity is going on X, which should be fun. Has that been busy, honey? X?
Yeah, kind of.
Oh, okay. Well, that's a good sign. All right, so let's see here. Let's see some good. Even if this is from Snowmo, even if there's a very strong Arctic air mass in place, it seems that it's always an option for storms to be closer to the coast and pull warm air, no matter what the pattern is. What has happened for the Arctic air to be strong enough to keep it far enough away, but not strong enough to suppress it? This is always a very, very fine, delicate balance. And okay, so when you have Arctic air in place and you have a very impressive Gulf Stream, this is true going back to the 1800s, you have a dynamic battle constantly. Now, we're in a temperate zone, right? So the Arctic air is kind of stretching out, right? And it hits and it has sustained power, but it's kind of out of its norm, right? So you still need, in our environment, in our location, a lot of factors to work together. So you could have a pure Arctic air mass in place, but if you get an easterly wind, those temperatures are rising, and you may start off as snow, and you may change over to sleet and freezing rain, but you will eventually change over to rain, even if you have a pure Arctic air mass. Now, you can end up with suppression depending on the location of all the upper level features with those Arctic air masses. So if you have a powerful upper level low, let's say to the north of Lake Erie, you're not going to get winter storms here because the storm track is going to get suppressed down to South Carolina, and they're going to get snow, and then they're going to be shut down for 3 months because they don't know how to shovel snow. Okay, so that's what happens sometimes. And it was kind of one of the concerns I had with this pattern, saying, gee, okay, we get Arctic air, but if the upper level low, the low around the Hudson Bay drops down into the Great Lakes, that could suppress the storm track. So, and if that happened, forget about it, because then we get complaints all over the place. Now it's cold and dry. No one's going to be happy about that. But it's always a delicate balance. And forecasting in the northern mid-Atlantic is incredibly difficult because of that. Because it is one of the few places on the face of the earth where you have the interaction of maritime Atlantic air masses, tropical air masses, desert air masses from the Arctic, and air masses from the Pacific, and then your polar air masses. So you get everything. And so because of that mixture of different air masses, basically culminating on the East Coast, it leads to a very, very complex combination. And if that combination does not unfold correctly, you don't get winter storms. This is why years like 95, 96 that everyone points out, or 2009, 10, okay, that year was a unicorn, okay? Though that was one of those winters where everything lined up perfectly. 95, 96, everything lined up perfectly. So those years when you get them, enjoy them if you like snow, because they're hard to come by and they're really amazing. And then some years we get snow droughts, and other years we get a lot of activity. Let's see. Do you expect substantial flooding for the weekend storm? Not as significant as what we saw with this storm, but still some moderate. It's not going to help matters, that is for sure. If you're already flooding, it's going to extend the period of flooding, unfortunately, and it's going to slow the decrease of the rivers. But not as bad as what we saw, because the rainfall rate won't be as intense, and the storm is moving quickly. I'm not expecting it to produce as much rainfall, staying under an inch and a half for many locations. Some locations may stay below an inch, so I don't expect it to be as bad, but I do unfortunately think that because of the additional rainfall, the duration of the current flooding is going to be extended as a result. Looks like the polar temperatures at 70 millibars and 10 millibars have cooled off a bit. Yep, they have. They should. Is there another round of warming on the way at that level? Minor, not anything to the extent we did see. This is typical. Usually the stratospheric warming hits its peak and then starts to decline. We do see a couple more surges, but not nearly as strong as what we just experienced. Also, it appears while 70 millibars is somewhat decent position for cold air to funnel to us, the setup at that level, and especially 10 millibars, doesn't look optimal. I kind of have to disagree with that. It's in a good position to transport air towards North America. And again, it lines up nicely to forcing the 500 millibar pattern set up properly. Any concern that prospective winter storms could either get sheared apart or suppressed south? There's always that threat. Doesn't look like in these next two, but of course it's something that we will have to watch and see how it evolves. Prediction on temperatures for Chiefs game. Like 5, 10? It's going to be brutal. It is going to be look, I love football, but you cannot pay me. And again, this is probably why I'm kind of a different fan. I enjoy watching my games, and this is true for baseball too. You will never get me to go to a baseball game when it's 90 degrees out, or 80 for that matter. I like staying at home watching the game. And there is no way I'm going to an NFL football game to freeze my butt off in a stadium where I could barely see the game and it's 0 degrees out. It's going to be brutal for that game. Absolutely brutal. And, the Dolphins don't do too well in frozen water. So I'm just saying, it's going to be pretty interesting. Will you do game forecast for all the playoff games? Probably not all of them. I just don't get enough demand for it, honestly. But I will say that let's see here. When is the Buffalo game? Let's see. Let me pull that up real fast. I got that. Let's go take a look at that because I know that's going to be a fun game to watch. And let's see here. They play on Sunday at 1 p.m. Perfect. That's about 18Z. Oh, wow. All right. Well, if you're a Buffalo Bills fan or a Pittsburgh Steelers fan, You could expect a lot of snow in that game. That is going to be one heck of a snowball. You got perfect winds aligned off of Lake Erie and Lake Ontario to support waves and waves of lake effect snow. That is going to be a very interesting game, that is for sure. And then I know that Tampa Bay and Philadelphia, they're going to be dealing with rainfall as well. We'll see surface temperatures play a role in the track and gradient for the storms. Yep, we talked about that. Absolutely. We're going to be keeping an eye on that. It's going to be a factor, and it'll probably get fleshed out more in the guidance once we get under 90 hours in terms of the impact, in terms of the rate of intensification. As we will be dealing with true Arctic air, if the storm works out, what will the ratios be? If we are in the 20s for this storm, then the ratios will be 15 to 1. But again, I'll be keeping an eye on that and studying that. I'll be using some BUBKIP data to make sure that we get that specifically right. Will the system be slowed down at all by the blocking that makes it longer lasting storm rather than just racing up the coast? The first one, maybe not, but the second one on the 20th has that potential, I think. Note that Steve is wearing the shirt. Yep, I decided to wear a shirt. It's more comfortable that way. Do you see potential 78 situation where one storm was followed not long after by a second stronger storm that both followed basically similar track? They're kind of two different storms than what you saw in 78, because in this scenario you got a Miller A storm, and then the second one is a Miller B Clipper type transition on the 20th. So I don't think it's the same scenario, but I do think that the track and evolution of that storm, of the first storm, will impact the evolution and speed of the second storm on the 20th. Let's see here. When you say immediate coast, would that include Vinland area, New Jersey? I'm located in Newfield, which, okay, so usually when I say the immediate coast, usually that's, if you could drive 5 minutes to the shore, that's the immediate coast. If you are like in Wildwood, Cape May, locations like that, if it takes you 25 minutes to get into the shore, you're on the coastline, you're in the coastal plain, but not on the immediate coast. With a true Arctic air injection, this should favor the Euro solution and benefit interior just northwest of big cities, with one storm and second storm favoring the coastal areas with higher ratio, possibly. I will say this, the European and the European ensemble guidance tends to handle Arctic air masses and the associated storms with them much better than the GFS guidance. This is due to the way that they organize their physics and the data collection. The GFS, for some reason, has a really difficult time with the density of the Arctic air masses and tends to over-suppress storm tracks, and then it recorrects itself about 90 hours out, typically. So then you eventually end up with the European solution. Was the most recent system stronger than forecast or right where you expected? It's pretty much what I expected, which was sounding like a freight train around here. I was doing one of the video discussions and we almost lost power.
A couple times.
Yeah. Lights flickering, everything. I can do without that, thank you very much. What is the state of the EP flux in the QBO? We still have a negative QBO, and we still have a pretty robust QP flux, which is allowing our polar vortex to be disrupted. The Gulf of Mexico also results in the U.S. east of the Rockies getting wetter than that is rather unique globally. Yes, it is. Yeah, definitely. Look, the United States and North America in general is aligned in such a way that has a lot of unique potential for rainfall, which is strategically why we're able to grow so much food, by the way. You haven't spoken about the EP flux in a while. Well, I just did, so let's see here. How much snow could coastal New York City get in Tuesday's storm best case scenario? I have no idea. Well, let's say 15 to 1, you get 1 inch of QPF. That'd be 15 inches. I'm not forecasting that, but let's just say hypothetically. Let's see here. your winter forecast zone 5 was expected to have near normal temperatures and above normal precipitation. Precipitation has definitely been off the charts, so that looks like it will verify, but temperatures so far have been averaging about 5 degrees above normal so far. Keyword there, so far. Let's see what happens after that Arctic air mass and see where we end up when we balance out. So that's kind of the idea. Like this, supposedly, the idea was that we'd get some Arctic air masses and it kind of balance everything out. So we'll see how that works. Could Storm 2 set the table for a third storm before the pattern relaxes? That's a possibility, but I'm not ready to confirm that yet. I want to see how the first 2 storms evolve and whether we have one more on the pike. I could certainly see a third storm as the pattern relaxes. That's typical when you see pattern relaxation, but I don't have enough data to really support that idea yet. So right now I'm just staying at 2 storms, and if I get more support for a third storm, I could certainly see that happening before we have a complete pattern collapse and we start to see more of a relaxation zonal pattern set up across the United States. What factors help decide whether this phase is early enough to get big storm or whether it phases late? Well, it all comes down to the timing of the short waves now. The pattern's in place. So we have the pattern that's in place. We have everything kind of locked in that respect in the larger scale. Now the question is simply, how do the individual short waves come down and interact? So let me go to this map here. Okay, so we have the pattern in place. This is tonight, all right? Now, in this pattern that we have, actually, let me zoom out and get this one right here. Okay, good. So here's our pattern right now. You have the block, very impressive negative NAO. You have your upper level low in the right position. You have your ridge over the west coast, and you have your short waves diving in. The real question now comes down to, when did short waves dive in? What is the orientation? What is the speed of each one? That's pretty much the final question as to what type of storm we get and how does it evolve and who gets what snow. That's the bottom line. That's the basic question. And we'll probably get a much better idea of what we're dealing with once we get under 120 hours, and then we'll see how it evolves from there. Now let's take a look at what we have on YouTube. Let's see. Wow. All right. A lot of questions once again. All right. Let's see here. Wanda asks, seems like every storm is a monster full of moisture. Is this due to El Nino? It's definitely a factor. Absolutely. El Nino typically supports above normal precipitation along the East Coast. There's also a factor of climate change as well, because we're seeing more higher robust precipitable water values, which is an indication of a warmer atmosphere because you have larger 500 millibar heights, and more moisture can be held as a result of that. Let's see here. I really wish we'd go back to the 16th and 17th century when we had snow on the ground for 4 or 5 months. I do not. I like indoor bathroom for one. I like the TV. I like medical. I like the fact that I don't have to shoot my own food. Or in this case, it would probably be bow and arrow. I guess, I don't know. But yeah, I am fine with being in this century. I like snow, but not that much. Let's see here. When will the next winter storm be the same like the one last night with a squall line? Not expecting that right now. Based on the data that we're seeing, the convective potential is much lower in this environment. One of the best ways to tell that is, and again, let me pull up this map right here. Okay, you see this feature right here? Let me zoom in. You see this spreading that's going on here? The last storm was far more robust, and this strong PVA extended all the way down towards the Delmarva Peninsula. This time, the strongest PVA is clearly focused over the Great Lakes, and the divergence and diffluence isn't as strong. So we don't have a strong rising motion, and so the potential for convective ability is a bit lower. Hypothetically, could a track west of 7040 be overwhelmed by Arctic air such that the rain-snow line is further east? Oh, absolutely. Here's the thing, right? With this track for our storm, there are several factors to consider here that we're going to study. For one, you have to consider the Arctic air, and then the Arctic air clashing with the warm waters, causing rapid intensification. Now, that rapid intensification would lead to, on the north and northwest side, rising motion of air. So you have strong lifting on the coastal plain, even though the track is a little bit to the west of 7040. That could then lead to such strong lifting that it overwhelms any type of warming influence from the Atlantic, and it pushes your rain-snow line off the coast. That's certainly a possibility. It's something that we definitely have to watch. I wouldn't be surprised if you end up with snow, brief period of snow, rain, sleet mixing in, and going right back over to snow and heavy at times. Someone misses Long Island. Let's see here. Love Bills playing in snow. You're going to definitely get that. Will you be looking for a Friday, Saturday storm to start projecting for Tuesday? What will you be? Pretty much just the establishment of the block. That's pretty much it. And the progression of the cold air transport on Saturday night, just to make sure that evolves correctly. Please bring snow to North Delaware. Okay. Do you think Central New Jersey, Old Bridge? Oh, this is Dylan, of course. I'm surprised he didn't ask about tornadoes. Has a shot of significant snowfall. Well, yeah, they have a shot. Absolutely. Yeah. How confident are you? It could be a bust or significant. I have no idea. Like I said, there's so much data that we have to go through first before even determining who's going to get what. But you have a really good shot. I'll put it that way. Good evening, Joseph. Hopefully the Chiefs can catch the ball. Yeah, tell me about it. Don't get me started on that. What do you see the MJO doing the rest of the month and into February? We covered that. Snow for Virginia anytime soon. Your best shot's going to be that 16-17 storm. Do we have any questions on X? Oh boy, we have questions on X. This is going to be fun.
Okay.
What do we got?
Hold on.
Holy smokes.
You can scroll through.
I will scroll through this. Let's see what we have. Someone been working out. Yeah. Well, yeah, I've been working out for like 20 years, so it should show at some point. Watch the Montana PNA Ridge. That is a great point. Yes. That is, whenever you have, here, let's go back to this here. Okay. So, when it comes to these winter storms, what you want to have is this ridge axis showing up right here. Let me go back here. Okay. So what you want to do is watch this ridge axis. If it lines up just right around Montana, game on. Simple as that. So great point. Jersey. If all comes together for Tuesday, can we be looking at 24 inches plus? I cannot say that. Nope. That storm has to move a lot slower for that to happen, and we need to have several hours of intense snowfall, which right now I don't have support for anything of that nature. Or the snow ratio would have to be off the charts, which would be incredibly unusual. So I don't have any data to make that type of forecast. Let's see here. The 18Z Euro delay. It doesn't go that far out for the storm so far, but certainly for the Friday night into Saturday storm, it certainly shows about a half an inch to an inch of rain. How are looking for snow in Morris and Sussex? Oh, you guys are good. Don't worry about that. Let's see. Wow. There's a ton. Holy smokes. Once we get a ridge through Montana, I-95 is good to go. Most times, yes. Especially if the Atlantic is favorable. Blizzard on Monday? No, not on Monday. Not going to call any blizzards. Nope. And someone's daughter wants to say, hi, Maya. Did I say it right? I don't know. I am horrible. Here, you check. I am horrible at names. I am really good at screwing up everyone's name. Maya? Is that right?
I think.
All right. Hi, Maya. There you go. Hopefully that worked out well. And if not, I apologize. But hello. How you doing? Let's see here. More questions shooting right through. We'll go back to the premium chart here. We're going to be busy. Let's see what we got here. What factors are you looking at for the pattern relaxation to end and a pattern setting up for the second round for potential winter storms? First of all, typically when you have this type of pattern set up, and you're seeing a stretch polar vortex, you usually get one more shot of a polar vortex stretching until we get consolidation. When we get consolidation, I think that will happen in mid-February, and that will lead to an end to our winter pattern completely towards the end of February. The middle of February, early to mid-February, right around, let's say, February 5th on through, let's say, the 20th, during that time period, we'll have the potential, but it's not going to be that great. There's going to be a lot of close calls. Something good? What factors are you looking at? Pattern relaxation. All right. How cold do you think it will get here with the Arctic blast? Probably teens and 20s. She's screaming, I'm famous. Well, there you go. Good deal. During the relaxation period, do you see temperatures normal or slightly above normal or much above normal? Given this year, the way it's been, probably much above normal. And I don't say that to be flippant. It's just that it seems like in this pattern, when there's been the chance for temperatures to really warm up, it has. But it won't last long. It'll be kind of like a spike, and then we'll be slightly above normal. A reminder that crops failed a lot during the Ice Age and people starved. Yes, I don't want that. I don't want any part of that. Is there a benchmark that would place Philly in the jackpot zone of a winter storm? Yeah, I mean, the 40-70 demarcation is usually a pretty good sign for Philadelphia. The problem with in those situations with Philadelphia is that sometimes the low pressure system develops off the Delaware coast, and by the time the storm matures, it's basically rocking and rolling in New York City and central New Jersey, but Philadelphia misses out on the worst. If you get a storm that sets up, let's say, around Virginia, and it tracks towards the benchmark, it's even good for Philadelphia. People always say water temperatures are too warm for snow, but wouldn't that make the storm much stronger? Water temperatures are too warm if you get an east wind. So here's the rule, right? The reason why a northeast wind or east wind is so important in the forecast is this. If you get a storm rapidly intensifying with a northeasterly wind, what happens is that you're transporting all the cold air down towards the coast. So you're increasing your thermal gradient on the coastal plain, which allows your low pressure system at the surface to rapidly intensify even more because you're enhancing your thermal gradient. But if that low pressure system track is originally on, let's say, on the North Carolina coast or over Virginia, then you're driving that thermal gradient inland because you get an easterly wind. This is also why a high pressure to the north of a storm is so important, because it can act as a kind of an anchor for that Arctic air mass or polar air mass If you don't have that anchor, then that easterly wind will overcome the polar and Arctic air mass that's in place until it gets to about the Delaware River Valley. What is the ice coverage of the Great Lakes right now? Very below normal. That's why it could get very, very interesting around the Great Lakes over the next 2 weeks. How cold do you think temperatures will get with this article? I think I already answered it. Basically, looking at a lot of teens and 20s over the interior, 20s and 30s along the coast. We get that snowfall. If it locks in, then you have to go colder because now your low temperatures are going to be colder as well. If the first storm provides a decent snow cover, will the snow help? I was just saying that. Yes. Yes, it will. I actually read your thoughts as you were typing them. Let's see, anything on YouTube? Let's see. If all the teleconnections are favorable, but the MJO is not, what dictates the pattern? That, ladies and gentlemen, is the challenge of long-range forecasting. And it kind of depends on what is the dominant driver. And this isn't always the same answer every season. Heck, even every month. Okay? So, in this scenario, where you're having such a strong disruption of the polar vortex, and it's amplifying the polar jet streams in the way it is, typically the polar jet stream and the high latitude blocking is what is the main forcing mechanism. But then the MJO kind of puts its little twist on it, right? So you have your dominant forcing, but then the MJO comes in terms of controlling the storm track. So you get your Arctic air in the mid latitudes, and the weather pattern doesn't care whether or not you get snow. All it cares about is the fact that it's balancing itself with the disruption in the atmosphere. So then your Arctic air masses get focused towards Ohio, the Great Lakes, New England, the Tennessee River Valley, but you miss out because of the MJO influence. So it's never one dominant thing. What you have to do is kind of figure out how these different features are interacting. And the way you kind of study that is by looking at the convection that's going on in the Pacific and try to make out if there's a lot of convection around the date line, will that support lower below normal heights along the southeast coast, which would increase the potential for East Coast cyclogenesis rather than a storm track through, let's say, the Ohio River Valley.
Honey.
Yes.
Godzilla or Kong?
Oh, Godzilla. That's not even a question. Do you expect that Tuesday or next Saturday's storm to be potentially more significant for coastal areas? It has the potential. I am in northern Carbon County, Pennsylvania. Had 13 inches with this Saturday's storm. Season to date, about 18 inches. Better than last year, right? What's interesting for me is that the models seem to be bullish for Tuesday's snow, even down to the coast, but at the same time, there's no high pressure on the surface map. Let's pull that up here. Okay, so in this case, you have a lot of convergence and confluence here. Notice kind of the packing that's setting up here. So let's go to the surface map. And let's see, where are we finding our high pressure system? Where's our low pressure system? You have a high out here, and here is your high here, funneling in. Okay, so you have a high pressure system up here. It's not strong in any way, shape, or form, but here's your high up here. The key with this storm track is not so much the high pressure system driving the cold air in, but the fact that the cold air is already in place and the subtropical jet streams is interacting with it. But you still have your high pressure system right here, right around just to the north of, let's see here, I just went blank, around Canada, basically around Quebec and eastern Quebec, right about here. To be honest, I never seen a storm end up further south than projected. Oh, I have. Oh, I definitely have. I've seen storms end up further south. The worst winter to me is not when it's warm, but when it's cold and dry and all the storms are down in North Carolina and we have no snow whatsoever. That just annoys the heck out of me. Because at least when it's warm, I can be comfortable when I go outside. You know, I mean, I prefer snow, but, you know, at the very least, I can go out and do things. But when it's cold, let's say it's 10, 20 degrees out and dry, that's just annoying. Do you think that most storm events come February will be snow for central New Jersey? I have no idea. Don't know. What can we expect for our first snow map for premium? Oh, that's a good question. I'm probably going to shoot for Sunday. I think by then I should have plenty of data to set that up. Maybe Saturday, maybe depending on the data that we get. But I would say definitely this weekend. Any questions on X?
I think this is a good question, actually. So,
Okay. Can you speak more about the ridge over Montana and why it's important? Okay, so when we study storms and evolution, we talk a lot about the orientation of troughs and ridges. And when we study a storm, the reason why the ridge axis is so important is that it's directly related to the amplitude and position of the trough over the East Coast. So if you have a ridge that is centered, let's say, over North Dakota, that's going to force this trough off the East Coast, and your storm development is going to be out over the Atlantic. This is a scenario where people say the storm is trending east. It's not trending east. The model guidance is recognizing the ridge axis is over Dakota, North Dakota, and South Dakota, and so the trough axis must support a storm development further east. On the other hand, let's say if this ridge axis is back towards, let's say, the coastal waters of the West Coast, right? In that case, what you end up with is a trough axis back towards Oklahoma and Arkansas, and you have a better potential for storm development over the Ohio River Valley and more likely a storm track towards the Great Lakes. Now, in this scenario, what you could end up with sometimes if you have a block in the Atlantic is a storm track that heads up towards the Great Lakes and then redevelops off the New Jersey coast or around the Gulf of Maine that can lead to freezing rain, sleet, and snow over the interior up towards the Green and White Mountains while rain continues along the coast. So that's why the ridge axis is so important, because it tells us what the orientation and position of those troughs and ridges are. And there we go. I just answered that question. Card just asked the same thing. We had one winter where pretty much had no negative NAO blocking and got snowstorm after snowstorm because of the ridge. Yes. Here's the thing. A negative NAO is really, really helpful in setting up winter storms. But it's not the end-all be-all. So if you have a positive NAO or a neutral NAO, it makes the potential for winter storms very difficult, but not impossible. When you have a negative NAO, it makes the potential for winter storms far more likely, but not a guarantee. I hope that explains that. And the position of those troughs and ridges over the west will determine how that plays out. And sometimes you can end up, and we had this one year where we had a deep trough around the Rockies, and this was during a La Nina year, where you had a ridge on the southeast coast, but you had an Arctic air mass dropping in, and so you had these waves of low pressure developed around Oklahoma and shot up towards the Delmarva Peninsula. And so we had waves and waves of low pressure system and snow and sleet and freezing rain over the northern mid-Atlantic while we had these low pressure systems track. No real blocking, just cold air pressing southward because of the positively tilted trough that's set up. So it kind of depends on the pattern that you're dealing with and what the tropical forcing is as well. And we are at 9 o'clock. I'm going to take one more any more questions on X?
Yeah.
Oh, geez. Wow. There you go.
It is a busy night.
Yeah, it looks like it.
You get there and there.
What do we got here? Okay. Do you think Tuesday's storm could be a big one for the big cities? I don't have details on that yet. I think it's the best potential we've had all year. Or 2 years. 4 years. Yeah. Okay. So there we go. It's the best potential we've had in, at the very least, 2 years. Does the contracting stratosphere resulting from the Tonga eruption lift the troposphere? Great question. Okay, so when the stratosphere contracts, right, the troposphere expands. Now, part of this is part of the influences of global warming too, because the thing here is this. When you're adding CO2 into the stratosphere, it causes cooling in the stratosphere, which I know you're thinking warming, it would cause warming, right? No. When the CO2 molecule interacts with ozone, it causes cooling. Same thing when you put in a ton of water vapor into the stratosphere, it's interacting with the ozone and creates cooling. This causes contraction. The contraction allows expansion of the troposphere, which is where we live. This is why we get above normal 500 millibar heights. This enhances warming of the atmosphere. So now you basically have 3 components. I didn't even mention methane, the increase in methane, combining at the same time to enhance the warming that we've been seeing. I think that we've been seeing that quite a bit in 2023. And I think that's part of why we've had one of the warmest years on record with these various factors combining together. You add in El Nino, there you go. Let's see here. EPO and PNA probably more important. No, it depends on the pattern. They're all important in one way or another. But it just depends on where we're at. It's climate cycles. It's certainly a factor, absolutely. Look, just because we added CO2 doesn't mean the climate cycle stops. But just because it's climate cycles doesn't mean that CO2 influence doesn't matter. So, there's that. And, I stay away from all the extreme stuff. Like, New York City is not going to be underwater anytime soon or anything like that. We're not going to turn into Venus. But we do have influences. And that's undeniable. We had some impressive ice events that winter, I recall. Yes. Typically in La Nina years, my primary concern is wintry mix events and ice events for the Mid-Atlantic. My snowfall potential goes down, although it's not gone. It's not impossible to get an active winter with above normal snowfall, but you really need everything to line up just right, and you need a very strong Arctic air mass to press down to crush the southeast ridge. Other than that, you're just going to get storm tracks cut up towards the Ohio River Valley. But typically, my La Nina years feature a lot of wintry mix icy events, and my El Nino years feature a lot of lake cutters and blockbuster winter storms. So the lake cutter comes in to build the negative NAO block, and then the blockbuster winter storms come in because of the negative NAO block that's been formed. And I just answer. I'm doing good. I'm answering questions before people even ask them. That's something. Do we have any more questions on X?
No, but a thank you.
All right. Awesome.
Detailed answer.
So with that, my voice is starting to go. I am going to call it a night. We have broken down the details of what I'm going to be looking for with our winter storm. It basically comes down to the timing of all these short waves. Let me bring up the map here. So, these short waves right here. We're going to be watching that evolution and study that and see where it goes in terms of the timing. I really like a storm track off the East Coast. I don't think a storm track on the coastal plain is realistic. I really like the idea of a benchmark type track storm. I don't know yet the snowfall ratio. I don't know the timing of the storm yet, and the exact track of the storm yet. So those factors all have to be worked out before we even talk about snowfall amounts. And I should have an impact map out for premium members by this weekend, because by that point we'll have a really good idea on the shortwave evolution, and we'll get this first the storm for Friday night out of the way. So maybe Saturday, definitely Sunday, we'll have that put out. That is it for tonight. Thank you again for joining, and as always, stay safe out there.